Hello everyone, welcome to latest update program. The topic of discussion is re-entry corridor in Gaganyaan mission. This topic relates to science and technology section of the UPSC CSE syllabus. Let's see why this is in news. India's Gaganyaan mission is progressing toward its first human space flight, bringing focus to safe atmospheric re-entry technologies. ISRO's successful re-entry experiments SRE 2007, CARE 2014 validated thermal protection, guidance, and parachute systems essential for crew safety. Now let's discuss what is a re-entry corridor. To return to Earth, a space capsule must exit its orbit by reducing its speed. This is achieved through a deorbit burn, in which the spacecraft rotates about 180 degrees and fires its engines opposite to its direction of travel. Because orbital motion is maintained by forward velocity, slowing down allows gravity to overpower the centrifugal force, keeping the capsule in orbit. As a result, the spacecraft leaves its stable circular path and follows a shallow, descending elliptical trajectory that guides it into the upper atmosphere. The re-entry corridor is a narrow atmospheric pathway that the spacecraft must enter to ensure a safe return. It lies between two critical limits. If the entry angle is too shallow, overshoot, the capsule may skim the atmosphere and bounce back into space, similar to a stone skipping over water. If the angle is too steep, undershoot, the capsule encounters dense air too abruptly, producing extreme deceleration and intense heat that can exceed the structural and human tolerance limits. How will the Gaganyaan crew module re-enter? ISRO demonstrated its re-entry capability through the Space Capsule Recovery Experiment in 2007, successfully showing that an orbiting capsule could be brought back to Earth safely. This capability was strengthened by the crew module Atmospheric Re-entry Experiment in 2014, which tested and confirmed the effectiveness of full-scale thermal protection and parachute systems required to withstand the intense heat of re-entry. The Gaganyaan orbital module consists of two components, the crew module and the service module. During return, the SM uses its thrusters to perform the deorbit burn, after which it separates and burns up due to the extreme heat of re-entry. Functioning as a semi-ballistic vehicle, it performs controlled maneuvers by adjusting its lift through bipropellant thrusters to reach the intended landing area. At lower altitudes, a three-stage redundant parachute system deploys, ensuring a safe splashdown in the Bay of Bengal, the mission's primary recovery zone. Now it's time to do a practice question. Consider the following statements regarding re-entry corridor. 1. It is a narrow atmospheric pathway that the spacecraft must enter to ensure a safe return. 2. If a spacecraft enters too steeply or too shallowly outside this corridor, it may burn up or skip back into space. Which of the above statements are correct? A. Only 1. B. Only 2. C. Both 1 and 2D. Neither 1 nor 2. Send the answer for this question in the comment section. Thanks for watching. For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.